Good morning, class. Let's finish off chapter 8 and look at section 8.4, estimating population proportions. Now, recall a population proportion P is the fraction or percentage of a population that displays a certain characteristic. Of course, when a population is very large, it is impractical or impossible to calculate P. A sample must be taken, and the sample information is then used to analyze the population. Now, we've already seen population proportions in chapter 5 using our binomial probabilities, right? Our binomial probabilities had a probability of success we denoted by P. And also in chapter 7, when we looked at the sampling distribution of sample proportions in section 7.3. Now, a fact, the best point estimate used for estimating the population proportion is the sample proportion. And remember, we denote this by P hat. This is read P hat because it looks like it's got a little party hat on. That is, P hat is the value we will start with when creating our interval estimate for P. So recall that P hat is given by x over n. And this is just a fancy way of saying the number of individuals that have a certain characteristic divided by the total number of individuals. Let's look at an example. A graduate student wishes to know the proportion of American adults who speak 2 or more languages. He surveys 565 randomly selected American adults and finds that 226 speak 2 or more languages. Estimate the proportion of all American adults who speak 2 or more languages. Now notice in this problem, the characteristic that we are focusing on are American adults who speak 2 or more languages, right? So we have a total sample size of 565, this is our N, and we see that 226 satisfy this characteristic, and this is what we would denote by our X here. So we will use P hat as a point estimate for P. P hat is x over n, remember the number that satisfy the characteristic divided by the total number that we've sampled. And we get, in this case, we get 0.4. So this tells us that approximately 40% of American adults speak 2 or more languages. Now, again, just like we said in section 8.1, it is not smart to estimate a population parameter using a single value. Instead, we create an interval estimate centered around our best point estimate. Constructing a confidence interval for the population proportion is similar to constructing a confidence interval for the population mean. The first step is to find the point estimate. In this case, we will use P hat. The second step is to calculate the margin of error E. So we're going to start with our point estimate, in this case P hat. In the last two sections, 8.1 and 8.3, we used X bar. And we're going to subtract E, and we're going to add E to create our interval estimate. When the sample taken is a simple random sample, the conditions for a binomial distribution are met, and the sample size is large enough to ensure that n times p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10, the margin of error of a confidence interval for a population proportion is given by the following. And again, this formula is shown on your exam 4 formula sheet. Now, just a side note, these conditions we saw in chapter 7, they just ensure that the bar graph or the histogram is symmetric so that we can approximate it using a bell-shaped curve distribution, similar to what we saw in section 6.5. Okay? But this is the important part. this is our formula for the error. Recall that most of our critical values can be found using the table found at the bottom of the page on our table B, right? So we're going to look up our confidence and we're going to find our critical Z value, Z alpha over 2. Let's look at an example. A survey of 345 randomly selected students at one university found that 301 students think that there is not enough parking on campus. Find the 90% confidence interval for the proportion of all students at this university who think that there is not enough parking on campus. We first find the point estimate p hat. Remember that p hat is the number that satisfied the characteristic divided by the total number sampled. In this case, we're talking about students that agree that there is not enough parking on campus. So out of the 345 students surveyed, we found that 301 agreed that there is not enough parking on campus. So p hat is approximately 0.872464. And remember, whenever we're using decimal values in future calculations, we're going to use this again. We want to use 6 decimals so that we guarantee that we don't make an error by rounding the number too soon. Okay, so you can use the exact value, the fraction, or if you're using a decimal number, which students typically prefer, remember to use 6 decimals. Next, we calculate our margin of error, right? So, and again, what we're going to do is we're going to take our point estimate and subtract and add our margin of error to get our interval estimate. We already have our point estimate. Remember, our best estimate for the proportion is the sample proportion. So now we need our error. Remember that our error is our Z times the square root of p hat, 1 minus p hat over n. We've already calculated p hat. So 1 minus p hat, a quick calculation in your calculator, gives us 0.127536. Recall that our sample size was 345. Now, our confidence level was 90%. So if we look back at our table, 90% represents a Z value of 1.645. So that's where this value is coming from. We get an error of 0.029542. We finish the problem by finding the endpoints of our interval. So the lower endpoint is our point estimate minus our error, gives us 0.843, and our upper endpoint is our point estimate plus our error, which is 0.902. We will not use our smartphone app for these types of problems since it requires, again, an in-app purchase, which I don't want to force you to buy an in-app purchase. So if you do have a TI-84, you can look at the book or email me to see how to utilize your graphing calculator. It's very similar. We're going to click the stat feature and we're going to highlight the tests. And then at the bottom, it's going to say Z interval proportion or something of that nature. I forget off the top of my head. But it says Z1 proportion interval or Z interval 1 proportion, something along those lines. So as we saw when estimating population means, it is often desirable to know the fewest number of data values required to obtain a certain level of confidence for our interval estimate. Doing some algebra, so again, if we just take our error formula and resolve for n, we get the following formula. So remember that our error was this, and if we resolve for n, we get this formula. Now, fine print, in our error we use p hat. Here we have p because we're going to estimate the value of p. So let's look at an example. What is the minimum sample size needed for a 99% confidence interval for the population proportion if previous studies indicated that P was approximately 0.54 and we desire no more than 2% margin of error? We notice that we are given the confidence is 99%, the proportion is approximately 0.54, and our error is 2%. We look up our critical value in table B and see that our critical Z value is 2.575. Therefore, plugging all these in, 0.54 for P, 1 minus P is 1 minus 0.54 or 0.46. And then our Z we just said was 2.575 and our error is 0.02. Using our calculator we get 4,117.6 whatever. But again, these types of problems, we always round up. So I'm going to round up to the next whole number and we get approximately 4,118.